All right. All right, let's go ahead and get started. So here is the plan for class today. Okay. Here's the plan for class today. We're going to do our last notes on vectors. Okay, then the next time that I see you, Thursday, Friday, I know prom and nails and hair.
I'm not going to do that on Friday.
That's okay. So the plan for Thursday, Friday, really Thursday for y'all since that's the B-Day, is that you're going to just have time to either finish today's homework, finish old homework. So Thursday, you don't have a notes, and then next week we'll review tests. Okay? All right.
Nope,
nothing to be scared. All right, so let's take a look at your notes. Okay, girls, we ready? All right. Okay. Also, I am recording your class. I'd love it. If you just be the best student you could be. Okay, so we have talked about vectors for the last 2 days. You can only add vectors with other vectors. Okay, and the reason why is that the way that you add vectors is you have to put both of the x's together and both of the y's together. So if they don't both have an x and a y, that would be a problem. Okay, you cannot add a vector with a regular number. Okay, so you can't do a vector plus 7. That doesn't make sense. Okay, because you wouldn't know, do I add it to the x or do I add it to the y? Okay, remember when you are adding your horizontal and your vertical components, you're going to put it in little pointy brackets, A, comma, B. Where this A would be the 2 x's added together, and then the B would be the 2 y's. So let's do example A. We're going to add the 2 x's together. So if I have 6, 1, comma, 2, negative 5, what are my 2 x numbers?
6 and 2.
Okay, what's 6 plus 2?
8.
Okay, so that's going to give me 8. Okay, then I'm going to add up the 2 y's together. So I have a 1 and a negative 5.
Are we adding vectors?
We are. So 1 plus negative 5, that gives me negative 4. Now, we already learned that last class. Okay. Okay, let's do the second one. We're adding the x's and the y's. So my x is a negative 2 and a 4. Add those up. That would be a 2. And then my y's are a 5 and a 0. 5 plus 0 is still 5. Now, if there was a multiplier on one of those vectors, okay, which neither one of those happen to have one. But remember, you would multiply first, then add the pieces second. Okay? So there is another way to add vectors. So how you just did it is algebraically. Okay, what that means is you just look at the vectors, add up the pieces. But you can also add vectors graphically, okay? So come down here to the bottom. We're going to work the exact same 2 problems, adding graphically. So your vectors should be sketched head to tail. And then addition is commutative, so it doesn't matter which vector you start with. If you're adding them, it should give you the same answer either way.
What is that say? Commutative?
Commutative. Okay, so now before we do the question, okay, let's try to lock in, please. Okay, before we work the question, I want you to notice that this and this are the same thing. Okay, so my answer should come out the same. Then this one and this one are the same thing. Thank you. All right. So let's do the first one. I want to add 6, 1 and 2, negative 5. Okay, notice that I already know the correct answer should come out to be this. Correct. Okay. So we're going to start with 6, 1. I want you to pick a spot on your grid and I want you to sketch that vector. So I'm going to start right here, but again, it really doesn't matter. Okay, and then 6 is my horizontal. 1, 2, 3, 4, 5, 6, and then up 1. Okay, we practiced that last class. Then when you're adding, the next vector has to start right at the end of the one you just did. So I graphed 6, 1. Now I'm gonna, it doesn't matter where the middle is, just graph it anywhere. Now I'm gonna graph 2, -5, but I have to start right here. So I'm gonna start here and I'm gonna go over 2 and then down 1, 2, 3, 4, 5. And the answer, okay, I'm gonna read this little double star thing right here. The answer or the resultant vector is gonna connect this first vector's beginning to the head of the final vector. So what I mean by that is that this pink thing is the answer. Where you connect from the original start point to the final end point. Okay? So the answer connects your original start to your final endpoint. That's called the resultant vector. Okay, and then now let's check our work to make sure we got the right answer. When we did part A at the top, what was our answer? 8, comma what? Let's count this pink vector and make sure it matches. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. 1, 2, 3, 4. So we know that we did it right. Okay. So we still got 8, -4. Okay, let's do one more like that. Okay, remember the order that you graph them doesn't matter as long as you connect them. So this time, let's graph 4, 0 first. So pick a spot. Okay, I'm going to graph 4, 0. So that'd be 4 for my horizontal. Up and down 0, there's my arrow. And then if I want to add -2, 5 to that, I have to start exactly where that tail ended and then count left 2, up 5. So if I start here, I would go left 2, up 1, 2, 3, 4, 5. And just to show you that it doesn't matter. Okay, and then remember that your answer should connect your original start point to your final end point. So from here to here, this pink vector is the resultant vector. And then if I go up and I check my work from when I did it algebraically, remember how I got 2, 5? So if I count the components of my pink guy, 2 and then 1, 2, 3, 4, 5, I see that I still got the same answer. Okay, so you should be able to graph vector addition. You should also be able to just do it by adding the exit. Okay, thing number 1. Are we all good on that? All right, turn the page. Okay, so skip down to right here in your packet. You have vector v equals. Okay, this is the formula that you're going to be using today. Okay, the double bars for v, do you remember what that stands for? It starts with the M. What? No. Okay, remember that the bars like this, okay, that equals the magnitude or the length of how long the vector is. So the first number is going to be the length. And you'll notice that both the horizontal component and the vertical component have the length in the front. Then if you already know the direction, you're going to use cosine in the X, sine in the Y, which is very similar to the unit circle. So let me show you how this works. This is the formula that you're using right here. Okay, it says vector V has a length of 8 and a direction of 130. Then put V equals pointy bracket. Okay, how long is it? What's the length? 8. cosine, what's the direction? Then it'd be 8 cosine 130, comma 8 sine 130. Okay, the cosine will always go in the x or horizontal component. The sine will always go in the y. Okay, look at W. It says W has length 15 and direction 265. Then I'm going to put W equals. My length is 15. Remember that goes in both parts. But my first one gets a cosine. My second one gets a sine. And then the direction goes into this spot right here. So it'd be 265 and 265. Okay. So rather than you just having the X and the Y off the bat, okay, for today, you're going to have to write the X and the Y using this formula that we have right here. Okay, now from here, if you are asked to add the vectors, okay, you have two choices. You could do it by hand, like I showed you with the picture, or you could just do what? Add the two X's and then add the two Y's. So that's what we're going to do here because that's a little bit easier. So when I add these up in your calculator, I want you to add 8 cosine 130 to 15 cosine 265. Okay, so 8 cosine 130 plus 15 cosine 265. Okay, I got negative 6.4. That is my combined X value. Okay, then I'm going to do the same thing for the Y's. So in your calculator, type in 8 sine 130 plus 15 sine 265. Now, if you want to be a little bit lazy, this is up to you. If you just re-highlight it, you can just change the cosines to sines, and then you don't have to retype the whole thing. Okay, is it easier? Up to you. Okay, so I got negative 8.8. Okay, then from there, all of the things it's going to ask you to do are the same things we've already done with vectors previously. It's going to ask you to calculate the magnitude. Do you remember how to do that? What's the formula for magnitude?
Y over.
Oh, that's for direction is tan y over x. What's the magnitude one though? A squared plus b squared. So it'd be x squared plus y squared, then take the square root. Now, question, I noticed that both my x and my y are negative. Will those negatives make it into either of these formulas?
So.
No. So in your calculator, I'm going to do 6.4 squared plus 8.8 squared. Then I'm going to take the square root. Okay, and since we've already rounded to get those numbers, we are going to use the decimal for the answer. So I got 118.4. The square root of that is 10.9. Okay, and remember, that's how long or the length of the resultant vector from adding the first two vectors together. It depends. You'll look at what your homework says. So usually if these are whole numbers, you're going to leave it in radical form. But if you rounded these to decimals, you're going to round this as decimal. Okay, last little part of this. In my calculator, I'm going to do second tan y over x. Is it 6 over 8 or 8 over 6? 8.8 over 6.4. Now, this first answer that you get is not the direction. It's called the reference angle. Oops, I took that out. Should be over 6.4. Okay, so I got 53.9. We're going to round that to 54 degrees. That's the reference angle. The remaining step to turn that into direction is to consider what quadrant it would end up being in. So remember, this is my vector. I have a negative x and a negative y. It would be in the 180 plus. So I'm going to draw you a little picture. I'd go to the left 6, down 8. That puts me in quadrant 3. Okay, and then if you want me to give you the formulas again, Amari already said it's 180 plus, which is correct, but here they are. In case you lost your other notes. So once I see that I'm in quadrant 3, I know it's gonna be 180 plus the 54, and that would be your direction. 180 plus 54 is 234. Okay, does that make sense? We had to look at the x and the y of the vector. So if my x is negative, I'd have to go left. My y is negative, I'd have to go down. Okay, we're gonna add one more thing. Okay, we're gonna add north, south, east, and west. Okay, so turn the page. Go ahead. Let me know when you're ready.
How's your day?
Huh? It has been the most boo-boo water of boo-boo waters.
Are you okay?
Yeah.
I hope it gets better.
It better be.
Watching your favorite video.
It's also like our week is like 3 more days of just like being after me. And that's why I'm like stressed out that I don't feel like I have like time to just.
Oh my God, that was
like
so relaxed
watching TV or just
Yeah.
watch TikTok. Anything besides everything.
Yeah.
All right. Okay, do you see this lovely north, south, east, west?
Yes.
Okay, we're gonna label it with angles because we're gonna pretend that it's also a unit circle. So I measure the angle from here. Okay. So if I'm perfectly east, how many degrees would I count that as? 0, because that's the starting point, right?
That's not what you asked.
Okay, that's okay. So perfectly east is going to correspond to 0 degrees. What would perfectly north correspond to? 90. Now, if north is 90 and east is 0, what would northeast be?
45.
45. Because northeast is perfectly down that diagonal. Okay, then west, what would that be? 180. What would that make northwest? 135. That's okay. Okay, and listen, the reason it's 135 is I would take 90 and then just add 45 more. Because remember, 45 is half of this section. Okay, then perfectly straight down. Do you remember what it is?
Yeah.
270. That makes, I'll give you the other two. Southwest is 225. And then southeast would be 350. Okay, now here's why that matters. Okay, listen. Here's why that matters. We're now going to take word problems where instead of you just having a vector, okay, a vector is going to represent a particular force. So for example, you have a ship traveling this fast on this course, and we're going to use vectors to solve those types of problems. So before we do that, let's just convert some basic cardinal directions to make sure you get the idea. Southwest, what is that the same as in degrees? 225. Okay, the next one says north 10 degrees west. Here's what that means. You're going to start off pointed north. That is correct. Okay, you're going to start off pointed north and then you're going to tilt 10 degrees west. So west is this way. That means I'd go 10 degrees this way. Would I add it to 90 or minus it? Add it, because if I start here, I'd go 90 plus 10 more. That gives me 100. Okay, next one. I want north 20 degrees east. So I'm going to start pointed north. And if I tilt 20 degrees east, am I going to add it or subtract it from 90? So it would give me 70, I heard is the correct answer. Okay, last one. I want south 25 east. So south is right here. If I tilt east, am I gonna add the 25 or subtract it? Okay, add it. So this is 270 plus 25 more. That would put me at 295. Okay, we get the idea? All right, let's do a problem. Go ahead and turn the page, please. Okay, we're gonna do number 6. Okay, so we're skipping to this one right here. Ooh, good. Okay, number 6. Okay, now listen, my hope is we only need to go through 2 of these. Okay, so let's everybody lock in. So Reese, let's get that little head up, give him a little poke, Hank. Okay, so you have 2 things that are happening. Shh, 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 shh. Okay, first thing is that you have a jet, and the jet is traveling through wind. So put jet equals and wind equals. Each of those 2 things are going to get their own vector. Let's start with the jet. How fast is it going? Okay, it says it's going 40 east of north at 400 miles per hour. So put 400 cosine, 400 sine. Okay, now let's talk about the direction. It says that I want 40 degrees east of north. So perfectly north is 90. If I tilt 40 degrees to the east, am I going to add it or subtract it? Subtract it. 90 degrees, take away 40, leaves me with 50 and 50. All right, you should have your jet written. Let's do the wind. Okay, it says the wind stream is flowing 30 degrees west of north at 50 miles per hour. So put 50 cosine something, 50 sine something. And then remember, I'm going to fill in the blank with the direction, but it's giving me the direction in terms of west and north, and I need it to be in degrees. So on your compass, you have one right here. Point perfectly north, tilt 30 degrees west. Do you add it or subtract it? Add it. How many degrees? 120. Very good. Okay. Okay, the next question is going to ask you to find the resultant vector. So basically what you're going to do is you're going to add the 2 vectors together, and that's going to tell you the plane's actual specifics, including the wind. So when I add vectors, remember it's x plus x. That'll give me my x. And then I'll do y plus y. And that'll give me my y. So go ahead and add them up. I'll do the y's if y'all do the x. Okay. So 400. Okay, so the y that I got is 349.7. Did anyone add the x? 232 point what? 1? Okay, thank you. All right, so step number 1 is you're going to take the jet and the wind, you're going to add them up, and then you're going to find the same 2 things that you already know what they are, magnitude and direction. Okay, let's do magnitude first. Okay, now I don't really want to get into the vector diagram, but I want you to think about it like this. Okay. Without really getting into the vector diagram, I want you to think about how long the vector is represents how strong the force is. So for example, if my jetliner is going 400 miles per hour, that would have been a really long arrow. Compared to my wind is only 50, that would be a pretty short arrow. So the length of the vector or the magnitude tells you the speed of the plane. So box the word speed, and I want you to write magnitude on it. because how fast the plane goes is going to be how long the vector is when you add them up. And remember, we already know how to do that. 232.1 squared plus 349.7 squared, then take the square root. 232.1 squared, 0.7 squared. So I got 419.7 miles per hour. Good. Now I want you to think about, okay, the plane, how fast did the problem say it's going? Okay, 400, but then when you consider the wind, it's actually going 419. So in this case, the wind is like helping the plane along, making it go a little bit faster. Okay, bottom two questions. We're going to find the reference angle, then the direction. Okay, reference angle, I'm going to do tan y equals. Y over x is 349.7 over 232.1. But then remember, when you put it in the calculator, you're going to second tan it. So second tan 349.7 divided by 232.1. Okay, and I got 56 degrees. Okay, that's the reference angle. Okay, and then the final step is asking you to consider direction. Remember, direction is that little chart, and it depends on what quadrant. It is going to say 56. Here's why. Go back and look at your vector. What type of numbers were the x and the y? They're both positive. So if I were to graph this, I would go to the right 232, up 349, and my vector would be in quadrant 1. And remember, in quadrant 1, they stay the same. So I'm going to put here quadrant 1 equals the same. So it's still 56. All right, we're going to run through one more and then we're done. Okay, turn the page to the back side, please. Really? Good. All right, so this time, we're almost finished. Okay, rather than a jet and wind, you have a boat in a tide. Okay, it's the same concept. So let's do the boat first. We'll do the tide second. Okay, how fast is the boat going? 500 miles per hour. Then it's going to be 500 cosine, comma 500 sine. And then in order for me to fill in this angle, I need to input the direction, but my direction is given to me in north, south, east, west, and I need it to be in degrees. So come over here to your compass. Okay, if I start out pointing south, how many degrees is that? 270. And then I'm going to tilt 25 degrees west. That would be this way. Do I add them or subtract it? Good. So 270, take away 25. That leaves me with 245 as my angle. Okay, next let's do the tide. Okay, read the next sentence and tell me how fast is the tide pulling? 40. So it's 40 cosine, 40 sine. Okay, then what's my bearing or my direction? It's south 45 east. So remember, south is still 270, but I'm tilting east. Do I add it or subtract it? Add it. So I do 270 plus 45, that gives me 350. All right. Next thing they're asking me to do is find the resultant vector. Remember, that means that I need to add them. When you add, you're going to add the x's together, then the y's together. Okay, so y'all add the x's, I'll add the y. Okay, so the y value came out to negative 481.4. And then what's the X? 183 even. Okay. All right, then from there, okay, we're gonna find speed, but remember, speed is the same thing as magnitude. Okay, it's just how long the arrow would end up being. So you're gonna do 183 squared plus 481.4 squared, then take the square root. Is it a negative 183? Oh, okay, thank you. Now, for here, it doesn't matter, but up here it will, so thank you. Okay, so 183 squared plus 481 squared, take the square root, and I got 515. Okay, so in this case, because the riptide is also going south with the boat, instead of it only going 500, it ends up actually hitting a speed of 515. Yes. Okay, top two or next two, we want the reference angle. Tan theta equals y over x. In this case, that's 481.4 over 183. Okay, then remember in the calculator, you're going to second tan that. Round it off to a whole number. And I got 69 degrees. Okay, then how do we turn our reference angle into direction? We consider the quadrant. So look at your original X and Y. What type of numbers are they? If they're both negative, then I'd go to the left 3, down 3. That puts me in this quadrant. What's the formula here? 180 plus. So I'm going to put quadrant 3 is 180 plus 69. So the final trajectory of the boat in the water, or the final path, would be 249 degrees, okay, at 515 miles per hour. Got it? Okay, now listen, you have almost an hour left in class. So on Thursday, you don't have any new notes. So if you can finish today's homework, Thursday is a complete free day. Okay, I would like for you to at least try some of the homework while it's fresh on your mind. If you don't finish, though, you can use Thursday.
Oh, you're skipping that one. Yeah. Okay, you're going to.
Yes.
You already had project for economics.
I want to see.